All right, so today we're going to be looking at problem solving with linear functions. As you can see from the objectives, students will be applying their knowledge of linear functions to create models and to solve problem situations. We're wrapping up linear functions, guys. As a matter of fact, tomorrow we'll be looking at a review for a test. That test will be on Monday. So we got a test coming up on Monday over all of this linear function. And I'll give you the review for that test tomorrow. All right, so let's go ahead and get started here. We're going to look at number one. Again, there are several parts to it. We'll be looking at each individual part together. So first of all, let's take a look at the scenario that we're working with. For number one, it says that the cost of building a new house depends on the number of square feet of floor space. So obviously, the bigger house you make, the more it's going to cost you, right? A little house doesn't cost as much as a big house. We all agree on that? Yes? A builder constructs the house on a lot that costs $40,000 and charges $60 per square foot. So you have to buy the land first before you can build a house. And this plot of land is $40,000. Then after that, the builder is charging you $60 for every square foot of house that he builds. All right, so let's take a look at part A. For part A, they want us to create a table with 3 data points. And I kind of got you started over here. If you notice, I've got a table over here with an X and a Y column. I even put in a couple of numbers for you underneath the X column. I put a 0, a 500, and a 1,000. So I want you to go ahead and copy this for me on your paper. Label it number 1, A. Draw yourself a table just like I have up here. Label it with X and Y columns. And underneath the X column, we're going to put the numbers 0, 500, and 1,000. Copy what you see right here on A. Yes, on that separate sheet of paper. Before I start filling in those Y columns, we got to make sure we understand what the X and Y columns are. So I'm going to go back to that scenario. It says that the cost of building a new house depends on the number of square feet. So we know that the Y values are the dependent, which in this case is the cost. So right above the Y's, I'm going to put down cost. So that's what the Y values are. It's the cost of building the house. So if Y is the cost, then what is the X? Well, remember, it says the cost of building this new house depends on something. And what does it depend on? The number of square feet. So that's what the X's are going to represent. They're going to represent the number of square feet. So again, Y represents the cost. X represents how many square feet the house is. So you'll notice that I put some numbers for you already. So we're talking about 0 square feet. We're talking about 500 square feet. And we're talking about a 1,000 square foot home. How much would it cost for each of these? Let me start with 0. If I had no house, how much would it cost? You would think 0, right? But remember, we got this piece of land. And how much are they charging for that piece of land? How much? $40,000. So even if we don't have a house, we still have to pay $40,000 just for that lot of land. So even if there's no house, you still got to pay for the land. All right, so let's go to the next one here, 500. What if we had a small house that had 500 square feet? How much would they charge me for that 500 square foot home? Well, let's come over here. Notice it says right over here, they're charging $60 per square foot. $60 per square foot. So what am I going to do with the 500 and this 60 over here? What am I going to do with those two numbers? Nope, not divide. Multiply. So go to your calculators, guys, and let's multiply 500 times 60. Because remember, they're charging me $60 for every square foot. How much? 30,000. However, that's not the number I'm going to put here in my table. Because 30,000 is just for the house. But remember, I'm still having to pay $40,000 for the land. So let's add those two numbers together. So the 30,000 plus the 40,000 for the land would mean that the total cost of this house is 70,000. So that's what we're going to put here, 70,000. So again, the Y values are the total cost, the land and the house put together. We're going to do this one more time. What if I have a bigger house? What if instead of 500 square feet, I have one that's 1,000 square feet? Well, let's do the same process. Let's multiply 1,000 times 60. What's 1,000 times 60?
100,000.
What's that? Oh, remember, right now all I'm doing is 1,000 times 60 is 60,000. But when I take that 60,000 and add it with the 40,000 for the land, we end up with a total cost of, is it 200,000 or 100,000? 100,000. Okay, so we're going to fill that in the last one. So again, what we've just figured out is what the total cost would be if we had no home, a 500 square foot home, and a 1,000 square foot home. So we've just completed part A. We just completed a table that has 3 data points. So we can check that off our list. We did part A. Now let's go over to part B. Find a linear function that represents the total cost of the house as a function of the number of square feet in the home. So they're asking me to write an equation, and we're going to write it in this form right here, called the slope-intercept form. Now we can do this the easy way, or we can do it the hard way. I'm assuming you guys want the easy way, right? And the easy way to do it, anybody know the easy way to find the equation? Notice what we have here. We have a table of numbers. Is there any way I can put that in my calculator? Where is it? And where is L1 and L2? What button is that? Stat. There you go. Everybody go to stats and then edits. Yeah, we're doing B right now. Stat and then edits. When you get to stat and edits, you're going to see L1 and L2. In L1, we're going to put our X values, which in this case are going to be the 0, the 500, and the 1,000. So put those numbers in for me. In L2, we're going to put these big numbers over here, the 40,000, the 70,000, and the 100,000. Get those numbers in for me. So you should have 3 ordered pairs in your calculator, just like we have over here on part A. Anybody know what to do once you have them in your calculator? What do we do next? Stats. Over to the right where it says what? Calc. And do you remember what number we use once we get to calculator? Number 4. So select number 4, and you got to hit enter how many times? 5. Enter. 1, 2, 3, 4, 5. I think it's 5 times. And it's going to give you something that looks like this right here. Y equals AX plus B, right? And they give you 2 numbers, a number for the A and a number for the B. What were those 2 numbers that the calculator gave you?
60 and 40.
60 and 40,000. Which means the equation that we end up with is Y equals 60X plus 40,000. So this is our answer to part B. We just wrote a linear equation given this information. Now before I go any further, I want you to look closely at these 2 numbers that the calculator just gave us. They gave us a 60 and they also gave us a 40,000. Those numbers sound familiar. Where have I seen those 2 numbers? Look guys, 60. That first paragraph they gave us. Did we see a 60 anywhere in that first paragraph?
Per square foot.
Yeah, remember they said they were charging us $60 per square foot. So that's what that 60 is. It's that number or that amount that they're charging us per square foot. This 40,000, wasn't that also in that scenario up there? What is that 40,000 representing? What is that 40,000 for? Well, it is dollars, but what is it for? What are we paying $40,000? Nope. Read it. Read it.
A
lot. It's for the lot. It's for that piece of land that we're building the house on. That's what the 40,000 is for the land. So these 2 numbers didn't come out of thin air. They represented how much they were charging us per square foot. That 40,000 is representing how much they're charging for the lot of land. Okay. All right. So now that we have the equation, that's going to make it a little easier to answer some of these other questions that we have. So let's go to part C here. Find the cost of a 2,200 square foot house. All right, so let's see. Remember, over here, the X's, those X's in our table represented the square feet. The Y values represented the cost. So if I want to know what the cost is of a 2,200 square foot home, all I have to do is replace the X with a 2,200. Put that in my calculator and see what I get. So go ahead and put that in your calculator. Let's do 60 times 2,200 plus 40,000. See what you end up with. All right, what do we get? All I'm asking you guys to do is put this in your calculator.
172,000.
172,000. Does everybody agree with that number? Everybody got that same number? All right. So if I were to purchase a home with 2,200 square feet, according to this, I should end up paying $172,000 for this house. Remember, that does include the lot of land. Now, that's part of it. We're going to do that again. What if it's a bigger house? What if it's 5,000 square feet? So I want you to do that again for me. Repeat the process. This time what I want you to do is replace the X with a 5,000. Put it in your calculator again and see what you get this time.
$34,000.
3,100,000.
Oh,
What do y'all get it?
3,100,000.
340,000. Is this right? Is that the number y'all get? Okay. So again, this is if we were to buy a 5,000 square foot home, which it makes sense, guys, because if you're buying a bigger house, then you should be paying more for that house, right? It should be a number bigger than $172,000 because it's a bigger home. All right, so we've just completed part C. Now let's go to part D here. Part D. Part D says if the buyer can afford to pay at most $2,220,000 for a home, including the lot, what is the largest house that he could build? So what's the biggest house this guy can build? All right, so let's come over here. We're going to use the same equation that we got earlier, this one right here. The difference is this time we know how much money we have. So we're going to replace Y with that $220,000. That's our Y. What we're looking for this time is the X. How many square feet? So what we're going to do is we're going to solve for X. This is an equation. This is those type of problems that I gave you back in the first 6 weeks where I asked you guys to take that test over and over and over until you made 100 on it. Okay, so that's what we're going to do here. So if I want to solve for X, the first thing I'm going to do is subtract the 40,000 from both sides. So you're going to need your calculator here. That's gone. So let's use our calculator. We need to subtract 220,000 minus 40,000. What do you end up with?
180,000.
180,000. That's right. We're going to divide it by 60. So let's take that 180,000 divided by 60 and let's see what we come up with. 3,000. So what does that mean for us? It means that if we have $220,000 in our pocket, that we can go out and build a 3,000 square foot home. Okay, that's what we're saying. 3,000 square foot home is the biggest that we can build. All right, so that's going to take us through part D. Part E. Part E, what they want us to do is they want us to come over here and sketch a graph of this function using the appropriate domain and range. Now, what I don't want you to do yet, guys, is draw the graph that I have over here. Because the graph that I have right now is not going to work for what we have over here. Because if you look at my numbers over here, the X's, I have a 0, a 500, and a 1,000. But if you look at my graph over here, my X values only go from 0 to 10. So the graph paper I have is not big enough right now. Matter of fact, if you look at the Y values, they go from 40,000 to 100,000. This graph that I have is not big enough. So we're going to have to fix that. And you're going to help me figure out what to use so that we can fix it. So here we go. Starting with the X's. Where am I going to start at? what number do I start with? Well, look at where we started. We started with a 0, so I'm going to leave that 0 alone. Question is, where am I going to end at? What number am I going to use? Well, if you look at my table, I go from 0 to 1,000. So I'm going to change it from a 10 to 1,000. All right. And I'm also going to change what I count by down here. I'm not going to count by ones, because that would take too long to go from 0 to 1,000. So help me out. What would be a better number to count by if I'm going from 0 to 1,000? 100? Let's try it. Let's see how good that works. All right, so not too bad. Notice down here we got 100, 200, 300, 400, 500, 600, 700, 800, 900. So yeah, that'll work. We can use that. We'll stick with that. What about the Y values? Where are we going to start at with the Y values? What's that? 40,000, all right. Remember, we're looking at the Y's over here, so we're going to start with 40,000. Where are we going to end at? What's the last number we're going to use there? Look at the Y values. What's the last number? What's the biggest number? 100,000. So we're going to use 100,000. Now look at this. That's way too messy here. Right now I've got it set up so that it counts by 150s. 150s is too small. I want to count by something a little bit bigger here. Anybody got a suggestion? What's that?
3,000.
3,000? All right, let's try it. 5,000? Let's try a little bigger here. Oh yeah, that doesn't look too bad. All right, we'll go ahead and use 5,000. All right, so we've got our window set up. So now that we've got it all fixed, now you can go ahead and copy what you see on my board here. So down here on the X's, we're going from 0 to 1,000, and we are counting by 100s. On the Y-axis, we're going from 40,000 to 100,000, and this time we're counting by 5,000. And the reason we had to do that is because what we're going to come and do now is we're going to plot each of these 3 points on this graph paper. If we did this right, everything should be able to fit now. So what I'm going to do is I'm going to go ahead and start by plotting the first point, which is 0, 40,000, and 40,000 would be right here. The next order pair I have is 500 and 70,000. So I'm going to come over here and find the 500 first. Then I'm going to find the 70,000, which is right here. There's the 570,000. And the last order pair I had was 1,000 and 100,000. So here's my 1,000 at the very end. 100,000 is way up here at the top. So there's that last order pair. So these are the 3 points that we put in our table. The last thing I want to do is go ahead and graph the linear function that we came up with earlier, which was y equals 60x plus 40,000. So what I'm going to do is go ahead and graph a line. That line of best fit that we talked about the other day, that goes through the points. This is the graph of those 3 points, including the equation y equals 60x plus 40,000. All right, so that's a lot of work for that one problem. Do you agree? A lot of stuff there. And you'll be doing something like that here on your own in a minute. However, before I cut you loose on your own, I'm going to do one more with you guys. Now, luckily, number 2 is not quite as bad as number 1, but there's still quite a bit of work to do. So, any questions on number 1 before I move on to number 2? We're all good, because you're going to get something very similar to this in a little while. All right, then, let's go ahead and go to number 2. Number 2, different scenario this time. For number 2, this time we have a computer system that costs $1,276.94. That does include tax. It says that an interest-free credit account can be set up to pay the computer system by making a down payment of 15% and making some monthly payments of $70. So you don't have $1,276.94 in your pocket. So you have to ask to charge it. So they let you charge it interest-free. So they're not going to charge you any interest. However, you do have to make a down payment of 15%. So you're going to have to pay 15% right up front. After that, you're going to start making payments of $70. That's what they're telling us in the scenario. So let's see what Part A is asking for. Part A, they want us to find the linear function that represents the amount owed in the interest-free credit accounts f of x after x months. So we're going to use x to represent the number of months. We're going to use f of x to represent how much money is still owed. So here we go. F of x. That's how much money we owe. That's what that's going to represent, how much money we owe. Now remember, here's where it gets a little tricky, guys, because remember, he had to make a down payment of 15%. So he's not going to pay the whole 100% of the bill, because he's already paid 15%, which leaves him with 85% of the bill. Because 100 minus 15 leaves us with 85%. So 85% as a decimal would be 0.85. So I want you to go ahead and start there, 0.85. We're going to have to pay 85% of the total cost, because he's already paid 15%. 85% of what, though? 85% of the bill, which was $1,276.94. That's what he has to pay. Now, according to this, it says every month he's going to pay $70. So every time we go over here, we're going to be subtracting from that amount. And how much are we going to subtract every month? Come on, guys. How much are we going to subtract it? How much? $70. So 70x. X representing the number of months. All right, so at this point, we've just answered Part A. We just came up with the equation. What we're going to do is we're going to use this equation to answer some of the other questions. So let's take a look at Part B. Part B wants to know how much would remain on the account after 9 months. So we're going to do this the easy way. We're going to use our calculators to find the answer. So what I need you to do is go to your calculators and go to y equals. And what I want you to do is if there's any equations that you have in y equals, so let's go ahead and get rid of them. Delete your equation or anything that you have in y equals. And what I want you to do is I want you to type in this equation for me right here in your calculator. You're going to type in 0.85 parentheses 127 or 100 and $1,276.94 minus 70x. Let's put that in our calculator. Rachel, let's put it in your calculator. Minus 70x. Now what we're doing is we're trying to use this equation to answer Part B. And the question again was how much would remain in the account after 9 months. So here's what you're going to do to find the answer. You're going to go to your table, second graph. Make sure you have the equation in. Once you have it in, go to your table, second graph. Now let me remind you, the x column. The x column represents the number of months. The y column represents how much money you still owe. So what I need you to do is go down the x column and find 9 months. And what do you see right next to 9 months? Okay, now we're talking about money. So what would that be in money? What's that number in money? 400 and there it is. So Part B, how much are we going to have or how much are we going to owe after 9 months? We're still going to owe $455.40. And we found that in our table. All we did was look for 9 months, and we can see right next to that 9 months is $455.40. C is a little backwards here. This time we want to know after how many months, so this time we're looking for the X, how many months would there be $245.40 in the account? So what I need you to do is go down the Y column and see if you can find the $245.40 $242.40. How many months would that be? TJ, where's your calculator? Why aren't you putting this in your calculator? How are you getting all the answers? How are you going to do this in a minute without a calculator? All right, what'd you say? How many months? 12. 12 months. Again, all we're doing is looking at our calculator, looking at our table, and we found $245.40 underneath the Y column. And right next to that, we can see it takes 12 months before we owe that amount of money. Now I'm going to skip over D for a second, and I want to go ahead and go to E first. E, what month would be the last payment on the account, and how much would this payment be? All right, so let's look at our calculator again. We're looking at the table, and I'm looking for how many months would it take for me to have that last payment. Where is it? I want to pay it all off. I want it to be clear. Come on, guys, look at your calculators. Look at your table. We're looking at E right now. The question was, what month? What month would be the last payment on the account? Is it the 11th, the 12th, the 13th, the 14th, the 15th, the 16th? What month would give us the last payment? Now remember, when we say last payment, we're trying to reach a total of 0. What? 15. And what's right next to 15? 35.399. Okay, so after 15 months, I'm going to put that right here. After 15 months, we would end up with our last payment. And how much would that very last payment be? What was that again? What number? $35.399. If we round 399, that would be the same thing as 40 cents. Okay, so it's going to take us 15 months to get to that last payment of $35.40. All right, guys, I tell you what, we're going to have to stop right there because we're starting to run out of time, and I do want you to try and do some of these on your own. So we're not going to worry about the graph right now.